Hello, grade 11. Welcome to another video lesson. Today we are continuing with our quadratic functions. Last lesson, I'm just going to quickly recap what we did. We learned that a function in the form of f of x, let's say we have function is x squared, we can graph a function of y equals 2, and we can apply several transformations. I can have a times f of x, and then we can also have x minus p inside, and then we can also have plus q at the outside. So this is what we've been doing for the past two lessons, where a is the scaling multiplier. A is the scaling multiplier. And what that means is it stretches the parabola. So that's A. And then we also have P here, which is going to be the horizontal translation, which means that it is shifting left or right. And then finally, we also have the plus q outside, which is going to be the vertical translation, which is the same as shifting up or down. So that's a quick recap of yesterday's and the lesson before. So let's do a really quick example. Let's say, for example, we want to graph the function of y is equal to half f of, well, let's use the actual function, half of x plus 2 whole squared plus 3. So this is our function, and we want to graph it over here. Now, this is going to be y, this is going to be x. Let's start with the 0, 0 over here. Actually, we don't have 0, 0. I'm going to start with just sketching out the normal function of y equals to x squared. This is the very normal one. And so with the new one, first of all, half of x, I'm going to use this gray color over here. Half of x means that every single point, the vertical point, is going to be half of the original. So it will look somewhat like this, because every single point here in the vertical space is half of the normal. So that's what the half will do. And then we also have a plus 2. We have a plus 2 over here, which will result in a left shift of 2 spaces. And then we also have a plus 3, which is going to be an upward shift in 3 spaces. So if I'm going to do a 2, negative 2, and then we have a plus positive 3 over here, this is where my new vertex is going to be. And then my new graph is actually going to look like this. So it has shifted 2 places to the left and 3 places up. That's the new vertex. And it's also more squished, not stretched, because it's only half of the normal one. So that was the past two lessons. Today, we're going to look at a vertex point and another point. So let's say, for example, we have some unknown function. We have some unknown transformation, okay? The original f of x is still x squared, but after applying a transformation, after applying an unknown transformation, the resulting, we have a vertex of new vertex meaning the endpoint is, let's say the new vertex is negative 2, 8. This is going to be class example 1 actually. Class example 1. So after applying the transformation, our new vertex is negative 2, 8, and it also passes through this parabola. The parabola passes through the point negative 1, 7. So what does that mean? So if we look at this original parabola of y equals to x squared, it applied some sort of transformation in which the new vertex is going to be at negative 2. So I'm going to go 2 spaces here. I'm going to go 2. So this will be negative 2. And then it goes down to negative, sorry, not down. It goes up to positive 8 over here. So this point over here is going to be our new vertex. And so if I try to sketch it out nicer, now that I know what it looks like, let me do it here. This is our y equals to x squared, and then we have negative 2, and then we have 8. So our resulting vertex is here. It should look somewhat like this. And then we also know that it passes through the point, if we zoom in, it passes through the point negative 1, 7. Negative 1, 7. Now, 7 is less than 8. 7 is less than 8, which means that it actually passes through this point. So there is actually no way for our parabola to go upwards. So I've sketched it wrong the first time, but it doesn't matter. All you have to do is make an amendment. If this point over here is your vertex, this negative 2, 8 is your vertex, and it passes through 1, 7 over here, this is negative 1, 7, it means that it has to go downwards. And if that goes downwards, then this also goes downwards. So our parabola is actually downwards now. It has been flipped. So this is what it can tell us. That extra point, it tells you whether it opens upwards or opens downwards. So this is our new parabola, and we want to find out the equation for it. Is it possible? Yes, it's actually not too difficult. So if you look at it, our vertex is at negative 2, 8, which means that if our new vertex at negative 2, 8 means that there was a translation of 2 units left and 8 units up. That's what it means. And so if I temporarily find our transformation function, it's going to be y is equal to f of 2 units left, means it's going to be x plus 2. This means plus means to the left. And then we also have 8 units up, so it's plus 8. That's going to be up. So we have temporarily found our new function, but that doesn't tell us whether it is stretched, whether it's upwards or downwards. So I still have to put an a in front of my function, and that's going to be my unknown scalar. Scaling factor. Unknown, oh, spelled it wrong. Unknown scaling factor. And we have to now find a. So we have to find a using what we now know. Oops. Oh, Yeah, okay, yeah, okay. Now we have to find A using what we now know. And what do we know? We know the plus 2, we know the plus A. All we need to know is substitute in some x and y in which we have 2 points. We have -2, 8, we have -1, 7. We can choose either of these coordinates and substitute the values into x and y. So we can choose either -2, 8 or -1, 7 and substitute the x and y values into the equation. So let's do that. I'm going to use -2, 8. That's the first one that I was given. That was the vertex. And so this is the x value, and this is the y value. When you substitute y into y, that's going to be 8 is equal to a, our unknown, f of x. I'm just going to directly write down our transformation, which was x plus 2 whole squared. I'm going to replace my x with -2 now. And then you will notice that this actually doesn't really work, because once we do this, -2 plus 2 will result in 8 equals 8, because it has cancels out. Okay, so 8 equals 2, a times 0 plus 8, so 8 equals 8. This doesn't help. And so what we realize is if we substitute in the vertex, let me circle it, if we substitute in the vertex, so if we substitute the vertex, we actually cannot find A. And so we have to substitute in our other given point, which was -1, 7. So let's do that now. So 7 is equal to a bracket -1 plus 2 whole squared plus 8. And then once you do that, 7 is equal to a times -1 plus 2 is 1. 1 squared is 1, so a remains a plus 8. And then I'm going to move the 8 to the other side to become -8. And so a is equal to -1. And so now that we have found a is equal to -1, I'm going to now substitute our a value into our function transformation. And so y is equal to a, which is -1, and then we have x plus 2 whole squared plus 8. And so -1 times anything is just negative of that. We don't need to write the 1. So y is equal to -x plus 2 whole squared plus 8. This is our function. This is our equation, function equation in vertex form. This is vertex form. Now, the textbook does tell you to rewrite the equation in general standard form. So we need to now rewrite our equation in general standard form. And so that means we have to multiply out the brackets. We have to expand that x plus 2 whole squared. And so we have y equals to negative. I'll just keep that there. X plus 2 whole squared is x squared minus 4x plus 4 plus 8. And then I'm going to apply the negative into all of the three values. Y is equal to -x squared, minus becomes plus 4x, minus plus becomes -4, plus 8, And then finally combine the minus 4 plus 8, we have y is equal to negative x squared plus 4x plus 4. So that is our general standard form of the transforming. It is transformed. This is the new equation, function equation. So this is how you actually do this whole lesson is all about doing this, and this is class example 1. So let's look at another one. Let's look at class example 2. It says finding intercepts from the standard form. Now this part is probably the easiest part, finding the intercepts, because finding intercepts, this part is easy because all you have to do is set x equals to 0, and then to find y intercept, and then we also have to set y equals to 0 to find x intercepts. I put seps because there can be two x-intercepts. So let's do an example. So we have class example 2. Determine the exact values of the x and y intercepts of the graph of the function f of x is equal to 3. That is the scaling factor. X minus 1, so it has moved 1 unit to the right, whole squared, minus 9, and so it has shifted 9 units down. Now, if I'm going to quickly sketch this, I know it would look something like the negative 1 over here means that it has shifted 1 unit to the right, and then 9 units down. So that's 1 unit right, and then also 9 units down. So the vertex will be down here, 1, 9. And then since our scaling factor is positive, it means that our parabola would open upwards instead of downwards. If it's negative, it would open downwards. So if I'm going to quickly sketch what this looks like, our vertex is here. It would look somewhat like this. So we have our y is equal to 3 bracket x minus 1 whole squared minus 9. So this is what it looks like if we sketch it out. It's not exactly the correct one, but at least we have a rough idea of what it would look like. And now we have to determine the x and y intercept. So we set the easier part is x equals 0. So let's do that. 3 of negative 1, 0 minus 1 is just negative 1 whole squared minus 9, and that's going to be 3 minus 9, which is negative 6. That's f of 0, okay? That is substituting our 0 value. And so if we look at that, does that look like negative 6? It certainly does. So that's a pretty good sketch that I made over there, setting our x value as 0. And then we have to find our two y values, x-intercepts, by setting y equals to 0. Now the question does say that we need to use the standard form. Now remember, when the textbook says standard form, it actually refers to the vertex form, which means in terms of the y equals to a of x minus p plus q. This is the standard vertex form. And so why does it tell us to use this standard vertex form? Now, if we actually try to multiply out this in terms of if we try to multiply this bracket here to find the general form, which is the ax squared minus bx plus bx plus c, you will realize that sometimes it doesn't factor out nicely. I can quickly show you. So if I quickly multiply out, set it to 0, and then we have 3 of x squared minus 2x plus 1, that is x minus 1 whole squared, and then this whole thing minus 9. If we multiply it out, it becomes 3x squared minus 6x plus 3 minus 9, and so it becomes 3x squared minus 6x minus 6, and then you can say, oh, I can factor out the 3 bracket x squared minus 2x minus 2, and when you get to this point, there is no way for us to factor this nicely. So this cannot factor nicely. There's no combination of the crossway in order to find that. So if I do negative 2, 1, or if I do 2, 1, if I do negative 1, 2, or 1, negative 2, none of these combinations will give me a negative 2 in the middle. And so we cannot use this method. So that's why the textbook tells us we need to use the standard vertex form. So let's go back to our vertex form. 0 is equal to 3 of x minus 1 whole squared minus 9. Now, what I can do, first thing, is I can divide both sides by 3. And so I have 0 equals to x minus 1 whole squared minus 3. So this is the first part. Now, I'm going to manipulate my 3 over here. I'm going to manipulate my 3. I'm going to rewrite it in a way that some of you may think looks kind of stupid, looks kind of dumb, doing something extra. So 3 can be written as square root 3 squared. So let me quickly write that, and you will quickly come to realize why I do this. So this is going to be square root 3. I'm putting it in a bracket and I'm squaring the whole thing. And so square root 3 squared is the same as 3, and so I'm not changing anything. But now you will realize that I have a something squared minus something squared. Does that ring any bells? It should, because a squared minus b squared is written as a plus b, a minus b. So we can manipulate our 3 over here to become square root 3 whole squared, and then rewrite this as a plus b, a minus b. So let's do that. So we have our x minus 1 as our a, and then we have plus root 3 as our b, all of this in a big bracket, and then we have another big bracket, then we have x minus 1, and then minus square root 3 as our a minus b. And then all we have to do now is take out the bracket inside, and so 0 is equal to x minus 1 plus root 3, and then we have x minus 1 minus root 3. This is our equation, and remember, we want to find a value in which y equals to 0. And so either one of these brackets, when it is 0, then that will be our x-intercepts. And so let's set it x minus 1 plus root 3 equal to 0. That's one side. And then we have x minus 1 minus root 3 equal to 0 as the other side. And so this is x is equal to 1 minus root 3 on this side. And then x is equal to 1 plus root 3 on this side. And so our two intercepts, x is equal to 1 minus root 3 or 1 plus root 3. These are our two answers, our x-intercepts. So if we go back to our diagram over here, this is going to be 1 minus root 3, and this will be 1 plus root 3 over there. So I know it's a little bit confusing. So let me quickly go back over here. When we get to this point, we found our after we substitute in f of 0, and we want to find our x-intercepts by setting y equals 0, we move away from the standard general form, and then we go into the standard vertex form, and then we have to manipulate our equation so that we can use the a plus b, a minus b factorization. So that will be able to find us the x-intercepts. So that is class example 2. Now, let's go to class example 3, and you will realize that we will do the same again. Class example 3. So it says, this time, it gives us a nice diagram that looks like this. Oh, sorry, that doesn't look too good. Looks like this. That looks a little bit better. And our vertex over here is at negative 1, 2, and then we have another point over here at negative 3, 1. So we are given a vertex, we're given an extra point. We can find the equation in vertex form straight away. Now, with the vertex being at negative 1, 2, it means that I have moved left 1 unit, and also it moved up 1 unit. And so I can rewrite my equation now. Y is equal to A. I'm going to leave it at A for now. Our scaling factor is unknown. And then multiplied by X. 1 unit left means plus 1. Remember, left is plus, right is minus. And then we have plus 1 unit up. Sorry, this is supposed to be 2 units up. 2, 2, 2. There, because this is 2. So sorry about that careless mistake over there. We all make careless mistakes, but as long as we check our work, then we should be able to spot them at any time. So after doing this, I want to substitute our our extra coordinate over there, substitute it into x and y. So we have 1 is equal to a bracket negative 3 plus 1 whole square, don't forget the square, plus 2, and then minus 3 plus 1 is going to be minus 2, so that's going to be 1 is equal to negative 2a, negative 2 squared is 4, so negative 4a plus 2, and then we have to solve for a, so we have negative 1 equals to negative 4a, which means that, oh, after you square it, the negative goes away, sorry. And so we have 4a equals to negative 1, which means that a is equal to negative 1 over 4. So maybe I'm speaking a bit too fast. That's why I'm making some mistakes. But if I want to go through it again, let me just quickly go through, because I know some of you may be a little bit confused. At this point, when I substitute in our negative 3 into the x, let's expand out the brackets now. And then the y into our y place, we have 1 is equal to a, negative 3 plus 1 is negative 2 whole squared plus 2. Then I'm going to square my negative 2, that becomes 4a plus 2. And then I'm going to solve the equation for a, and so when I move the 2 over, it becomes minus 2, so 1 minus 2 is negative 1 equals to 4a, which means that a is negative 1 over 4. Then I'm going to substitute my a back into the equation. Y is equal to negative 1 over 4, bracket x plus 1 whole squared plus 2. That is my equation in vertex form. And that is the standard form according to the textbook, standard vertex form. And then in part B, we want to find the x and y intercepts of the graph algebraically. And so, first thing, I'm going to set f of 0 to find the y-intercept. That's the easy part. And when we do that, we have f of 0 is equal to negative 1 over 4, bracket 0 plus 1 whole squared plus 2, and then that is 0 plus 1 is just 1. 1 squared is 1, times anything it's itself, so we have f of 0 is equal to negative 1 quarter plus 2, and so 2 is the same as 8 over 4, and so 8 over 4 minus 1 over 4 is 7 over 4. So f of 0 is 7 over 4. And if you want to know what that is in decimal, 7 over 4, that is the same as, or 1.75 in decimal. And then we want to find now the x-intercepts. We want to find these two values. We want to find the x-intercepts. And so in order to do that, we want to set y as 0. Y equals to 0. That is the 0 value of y. So 0 is equal to negative 1 over 4 x plus 1 whole squared plus 2. And then I'm going to do the same thing that I did a while ago of making this whole thing into that a plus b, a minus b, the a squared minus b squared. And so in order to do that, I'm going to rearrange this. You see, this is plus and this is minus, so I'm going to write this as 2 minus 1/4 of x plus 1 whole squared. I don't like to deal with the 1/4, so I'm going to multiply both sides by 8. Sorry, by 4. Multiply both sides by 4, because 0 times 4 is still 0, so I can still write this as 0. And when I multiply both sides by 4, this becomes 8 minus x plus 1 whole squared. Now I'm going to rewrite my 8 into root 8 whole squared. So that will be square root 8 whole squared minus x minus 1 whole squared. Then I can rewrite this as a plus b, a minus b. And so 0 is equal to square root 8, that's a, plus our b, x minus 1. And then we have our a, which is 8, square root 8, minus of x minus 1 there in a bracket. So we're almost done. All we need to do now is expand out the brackets inside. So we have 0 is equal to root 8 plus x minus 1. That is our first bracket. And then we have root 8 minus x minus minus becomes plus 1 in our second bracket. So this is our two equations, so our two brackets. And then we got to set either of them as 0. So let's do that. On the left side, we have root 8 plus x minus 1 equals to 0. And on the right side, we have root 8 minus x plus 1 as equal to 0. And then we have to find x. So x is equal to 1 minus root 8 on this side. And then x is equal to 1 plus root 8 on this side. So that is our two solutions. So if we look back up at over here, this should be the 1 plus root 8, and this should be 1 minus root 8. You can enter into your calculator to find the exact decimals. 1 minus root 8, that will be negative 1.83, and then 1 plus root 8 is going to be 3.83. And it looks somewhat similar, maybe. And so that's how we find the intercepts of the x-intercepts. So that's it for today's lesson. Please do the assignments. If you have any questions, please email me, or you can write a comment in this video, or let me know some way or another. And I will try my best to get back to you. So that's all. See you all next video lesson.